Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Today we'll talk about the conservation of energy. Okay. Conservation of energy principle says that energy can neither be created nor destroyed. It can only interchange forms. Okay. There are various forms of energy like kinetic energy, potential energy, solar energy, nuclear energy, chemical energy. So from one form of the energy, it gets converted into another form, but it is never created or destroyed. Okay. For example, on Earth, most of the energy we get from sun. So solar energy gets converted into all different forms of energy, like chemical energy and the fuel, and even the solar photovoltaic cells. So that again is a kind of chemical energy conversion of the solar. Likewise, the fuel, of course, these are basically plant-based stuff, and long back they got buried under earth, and that's how it became either in the form of gas or in form of coal. It is now available in the form of fuel. But again, it is a change of energy from one form to another. Okay. Now, let's have an evidence or verification that the conservation of energy is a valid principle, and how we can see it with an example. Suppose this is a small ball which has been put at height h from the ground. Now in our earlier video you understood that if at ground h is equal to 0, and therefore potential energy U will be equal to 0. Now the ball is brought at height h, right? And this ball from point A at height h from the ground is released. So it will fall down. At some point of time it will reach to point B, and it will have a velocity v1, right? Its initial velocity was 0, its velocity will keep increasing because acceleration due to gravity is acting downward, and then it will attain a velocity v1. Again, after this point, its velocity will continuously keep increasing, and finally it will hit the ground at point C, when its velocity becomes v. Okay. Now, if we ignore air friction, then basically there are only two kinds of energies involved. One is potential energy U, and another is kinetic energy K. Okay. Sum total of this U and K is total mechanical energy. Okay. So total mechanical energy is equal to potential energy plus kinetic energy. Because we have ignored friction, so there is no other form like heat and all is not involved in this example, right? Now let's try understanding that whether the total mechanical energy is conserved. If it is conserved, it means its value at each point will be the same, like at point A, point B, and point C, it should be same. Then only it is called conserved, right? So let's look at that. Let's do the analysis. At point A, what happens? At point A, the potential energy, because it is at height h, will be equal to mgh. No brainer, it is very obvious. What about kinetic energy? Kinetic energy will be equal to half times m v square, and in this case v is equal to u equal to 0, therefore it will be half into m into 0 square, which is 0. So then total mechanical energy, if I write this as m, then total mechanical energy m, which is nothing but u plus k, will be equal to mgh plus 0, which is equal to mgh. Correct? So this is the total mechanical energy at point A. Let us look at what happens at point B. Okay. At point B, what happens? When the object comes at point B, let us identify that what will be its potential energy. The object has come down x distance. It means the remaining distance from the ground is only h minus x. So therefore its potential energy will be m into g into whatever is the distance from the ground, that is h minus x. Right? So we can write this as mgh minus mgx. That is the potential energy of the ball or the object here at point B. What about kinetic energy? Kinetic energy, we know that it is equal to half of m times velocity square. At this point the velocity is v1, therefore it will be half m times v1 square. So to find the value of the kinetic energy, we need to know what is v1 or v1 square. So let us find that out. That we can find with the equation of motion. Because when the object started, its initial velocity was 0, and at point B when it reached, then its final velocity became v1, and the object is falling under acceleration due to gravity. So therefore acceleration A is equal to z, right? So therefore we can use the equation v square is equal to u square plus 2a into x or s or whatever. In this case it will be because it is in y direction, so we can take y. Okay. And therefore we can write u square is equal to 0, so it is 0 square plus 2 times acceleration is equal to acceleration due to gravity, so we have g, and the distance covered is x, right? From point A to point B, it is x. So therefore v1 square, v is equal to v1, therefore v1 square it will be, or we can write it here just for clarity, because here we have used the formula and then we are putting the value. So v1 square is equal to 0 square plus 2gx, and therefore v1 square becomes equal to 2g times x. So if that is the case, then if I put the value of v1 square in this one, then kinetic energy k will become equal to half times m into v1 square, and v1 square we know it is 2 times g times x. 2 and 2 cancels, so this becomes mgx, correct? So then I can find out what is the total mechanical energy. Total mechanical energy m again is equal to u, that is potential energy, plus kinetic energy. Potential energy we know that it is mgh minus mgx. That is potential energy. And kinetic energy is mgx, so we can write plus mgx. And therefore, these and these two cancels, and therefore it is again equal to mgh. So what do you find? That the total mechanical energy at point A was mgh. Total mechanical energy at B is also equal to mgh, which gives us the clear understanding that at least at point A and point B, the mechanical energy is conserved. It is the same, right? What about point C? Let us look at point C. At point C, which is third position, this is second position. Second position, which is point B. At third position, which is point C, which is at the ground. At the ground, height becomes equal to 0. Therefore, u is equal to 0, which I have already earlier also written, and we also always go with that assumption that at the ground we take the potential energy equal to 0. Anyway, U is equal to mgh, h equal to 0, therefore U will be equal to 0. What about kinetic energy K? Again, we need to look at that kinetic energy K will be equal to half times m times v square. The final velocity has become v. How we will get the value of v square? Again, we will have to use the equation of motion. Let's use that equation of motion. Maybe here we can write. The final velocity is v. Initial velocity coming from here was 0. And the distance covered is 2 times g times the total distance covered is h. From here to here it is h. Therefore, v square will be equal to 2 times g times h. Correct? So, if I put that value of v square here, it becomes half into m into 2 into g into h. And then again 2 and 2 cancels and this becomes equal to mgh. So, what we notice that the total mechanical energy now will be, which is m, that will be equal to u plus k, and u is equal to 0 and k is equal to mgh, and therefore total mechanical energy becomes mgh, right? So at point A also total mechanical energy is mgh. At point B also it is mgh, and at point C also it is mgh. Therefore, the total mechanical energy of this system, that is ball and earth, that system is conserved. Hope you would have understood with this example what is meant by conservation of energy. Thank you.